Hello. Today we are going to discuss about the inverse trigonometric functions. First, let us discuss how sine inverse x defined. Okay. You say the sine inverse x is the inverse function of the function sine x. We know that a function is invertible only if it is 1, 1 and on 2. So in order to get sine inverse of x, we have to make sine x 1, 1 and on 2 first. Now domain of sine x, you know it to be all real numbers and the range is -1 to 1. For on 2, we'll make the codomain as range, so problem is solved out there. But the problem is, now this function is not 1, 1 because we know that there are many values of sine x. For example, sine pi by 6 is 1 by 2. Again, sine pi by 6 will be 1 by 2, showing us that the sine x is not 1, 1. There are infinitely many numbers for which sine x will keep repeating its values. So that is the problem. So unless we sort out this problem, we cannot discuss about sine inverse of x. Now question to be asked, which part of R we have to rearrange this domain, because for some values of it we are getting the recurring values. The question is, which part of this R will neglect, or we can say which part of this R will make a new domain so that this function becomes 1, 1. Okay, for that we need the graph of sine x. That is going to help us because it will tell us clearly which part of the graph we have the repeated values of fx, that is sine x. Let us see. Sine x, the graph is here it is 0, here it is pi by 2, pi, 3 pi by 2, 2 pi and so on and so forth. This way it is minus pi by 2, minus pi, minus 3 pi by 2. Okay, now if we observe carefully, we will find that for the values of x beyond this minus pi by 2 here, the values are going to repeat. You see, we are getting the same values the moment we go beyond minus pi by 2. The same thing will happen the moment we take some values of x beyond pi by 2 this way. The values will repeat. So, if we'll restrict the domain R into one of these intervals, minus pi by 2 to pi by 2, or pi by 2 to 3 pi by 2, this part, or this part, the function seems to be 1, 1. So that is this one of these interval will be our new domain. Okay, so one of these interval, infinitely many intervals we can take as the domain of sine x, so that sine x become 1, 1 and on 2, and there is a possibility that another function will run from the range that is -1 to 1 to the new domain. Okay, that is how sine inverse will come into exist. Okay, this is a very important point we need to understand, because sine x is not readily 1, 1 and on 2, that is not readily invertible. So we have to make this adjustment in order to make sine inverse x even exist. Okay, so what we have learned, if we make this adjustment, if I restrict the domain of sine x from R to any one of those, but we'll go for minus pi by 2 to pi by 2. This is the midmost interval, and it is taken universally as principal value branch of sine inverse of x, to -1 to 1. Now this function sine x is 1, 1 and on 2. Again, so there exists a function sine inverse x called inverse of sine x. which will now run from minus 1 to 1 to minus pi by 2 to pi by 2. Okay, so this is how sine inverse x came into exist. One must note here that sine inverse x is not equal to 1 by sine x. We know that 1 by sine x is cosec x. It is in fact the inverse function which is running from the range of sine x to restricted domain of sine x. Okay, so this is how the sine inverse x defined. The same thing for cos x. For cos inverse x also, the same thing will happen. How cos inverse x will define them? Again, the domain of cos x is all real numbers. Range is minus 1 to 1. Again, there are infinitely many values of r for which cos x is keep giving us the same values, showing us that it is not 1, 1. So we have to restrict the domain of cos x, that is r, to something. For that something, again, you need the graph. You have to work on and find out which part of the graph the values of x, fx is not repeating. So that part of the graph will take and will restrict the domain so that this function will become 1, 1. Okay, 1, 1 and onto. The moment it becomes 1, 1 and onto, that is invertible, another function will run from minus 1, 1 to the restricted domain of cos x. Okay, so that can be seen from the graph. I'll advise you to do it yourself, and I'm just writing it here. Cos inverse x will be defined from 0 to pi, minus 1 to 1 to the restricted domain, that is 0 to pi. Okay, so we have to restrict the domain of cos x r to 0 to pi so that the function becomes 1, 1. It is already on 2. We have made it on 2. Okay, so that is how the rest of the trigonometric function also will define. Tan inverse x will be defined from all r to open interval minus pi by 2 to pi by 2. Cosec inverse of x will be defined from all r minus 1 to 1 to minus pi by 2 to pi by 2 minus 0. Sec inverse x will be defined from all r minus 1 to 1 to 0 to pi closed interval minus pi by 2. And cot inverse of x will define from r to minus pi by 2 to pi by 2 minus 0. Okay, so these are called the principal value branches of sine inverse, cos inverse, tan inverse, sec inverse, and cot inverse. And principal value branches are the range of this inverse trigonometric function or restricted domain of the original function, that is sin x, cos x, tan x, sec x, and cosec x. Okay, so let us discuss two very important properties. The first, property 1, is sine of sine inverse of x is equal to x for all x belonging to minus 1 to 1. Okay, so let us discuss and try to draw the graph of it. Okay, the domain of this function means what are the values of x we can take. Just recollect, sine inverse x, it is coming out of minus 1 to 1, so domain of f is minus 1 to 1 closed interval, and range of f, sine of sine inverse of x. Sine inverse of x will go from minus pi by 2 to pi by 2. The range of sine inverse of x is minus pi by 2 to pi by 2. So sine value will go from minus 1 to 1. So this function, the domain is also from minus 1 to 1. and range also we are going to get from -1 to 1. Okay, and how this function is defined, if I consider this one to be y, so all I need is y equal to x, that we know. There's a line like this, y equal to x from -1 to 1. So this will be the graph of sine inverse of x equal to x. A similar graph will be for y equal to cos inverse of x, y equal to tan inverse of x. I'll draw y of cosec inverse of x. Now for this function, the domain is all real numbers except -1 to 1, and the range is also the same, all real numbers -1 to 1. Okay, so if I try to draw the graph of cosec inverse of x, the graph will exclude all the values from -1 to 1 and the other way around. Sorry. So the graph will be y equal to x, y is equal to x because cosec inverse of x is equal to x for all x satisfying this. The same thing, this one is nothing but this modulus of x greater than equal to 1 means either x will be lesser than or equal to -1 or x is greater than equal to 1. This is exactly this. Okay, or otherwise this. The same graph will be for sec inverse of x. Okay, the same graph will come for sec inverse of x. Now let us go for the second property. Okay, this property is just saying us that sine inverse of x is x, cos inverse of x is also equal to x. We have to somehow remember that this x belonging to -1 to 1. Tan inverse of x equal to x for all x in real number. Cosec inverse of x equal to x for all x satisfying this, modulus of x greater than equal to 1. Sec inverse of x equal to x for all x satisfying this, and cos inverse of x equal to x for all real numbers. Okay. Now we are going for the second property. This very, very important property coming up. Property 2. This one is just the other way around. And here we have to learn something very, very important. And this property, second property, will be a great help when we'll go for calculus. It is going to help many a times in the calculus. The property says sine inverse of sine x is equal to x. Sine inverse of sine x equal to x. Now sine inverse of sine x equal to x, this is true only if x is lying between -π/2 to π/2. See, x, we have that time we have restricted the domain. So domain of this function is, if I'll try to write domain of this function, x can have all real numbers. But this particular result is true for only this. So what about the other rest? Because domain of this function is all real numbers. What about the rest of the values? We have many values, many other rest of the intervals. What about those? And the range of this function, let us find out. Range of this function. This x is free to take all real values. Sine inverse of anything, we know that the range of sine inverse x is -π/2 to π/2. So range of this function is -π/2 to π/2 only. Okay. Now let us discuss this. What will happen to the values of x which are not lying here? If it is lying here, this is the value. So we are going to discuss what if x is not lying here. What will happen then? Okay. So let us go for it. let y equal to fx equal to sine inverse of sine x, and y is belonging to minus pi by 2 to pi by 2 range of the function. Now we'll get from here sine y equal to sine x. So let us solve it. What do we get? Y equal to n pi plus minus 1 whole to the power n into x for all n belongs to z. It's a set of integers. Now put n equal to 0. What will get? Y equal to x. So y is lying between minus pi by 2 to pi by 2. So x also will belong to minus pi by 2 to pi by 2. So this is actually telling us the first thing what we have said. Now if x is lying between minus pi by 2 to pi by 2, then this fx will give us exactly x. Okay, that is what this property is telling us. Now we are going to find out what if it is going for some other interval. That is what our aim was. So put n equal to 1. So what we'll get y equal to pi minus x. Okay, so y equal to pi minus x. We know that y is belonging to, because the range of the function is not changed, so minus pi by 2 to pi by 2. So pi minus y we need. So minus y also will belong to minus pi by 2 to pi by 2. You see what I have done? Inequality, I have given the negative sign, so it has got reversed. But since the endpoints were same, so it has not, ultimately it has not changed anything here. So minus pi by 2 to, I'm going to add pi minus pi by 2. Here I'll get pi minus y, and here I'll get pi plus pi by 2. So I'm going to get here pi by 2, pi minus y, 3 pi by 2. Now this value, pi minus y from here, pi minus y is exactly equal to x. So x will lie between pi by 2 to 3 pi by 2. Now this is the answer now. When x is lying in this interval from pi by 2 to 3 pi by 2, y will take the value of pi minus x. This is what the learning point is. When x will lie from pi by 2 to 3 pi by 2, the value of the function will be pi minus x, no longer x. It has changed. Now we'll go for some other intervals also. Put n equal to minus 1. Again, let us put there. So we get y equal to minus pi minus of x. Okay, again y is lying between minus pi by 2 to pi by 2. Okay, minus pi by 2 to pi by 2. So what we need here, x will be equal to minus pi minus y. So I need minus y basically, minus y, minus pi by 2 to pi by 2. Then I need minus pi. So minus pi makes it minus 3 pi by 2, minus pi minus y, and minus pi will make it minus pi by 2. And this one is from here is exactly x. So when x is lying between minus 3 pi by 2 to minus pi by 2, the value of y will be minus pi minus x. Okay, so this is what we need to learn. Let us go for one more value, that is put n equal to positive 2. So what we get from here, y will be equal to 2 pi plus x. Again we'll find out, work on y is lying between minus pi by 2 to pi by 2, because that was the range of the function. And y, we need x, so x will be y minus 2 pi. So minus 2 pi we will do y minus 2 pi. So here minus 2 pi means minus 3 pi by 2. And here minus 2 pi means minus 5 pi by 2. So and this one is nothing but x. So when x is lying between minus 5 pi by 2 to minus 3 pi by 2, y will be equal to 2 pi plus x. And if we put x equal to put n equal to minus 2, we'll get this. Most probably we'll get y equal to x minus 2 pi. Okay, so let me write down all these values. Let me write down all these values in a table before we proceed to the graph. Okay, let me write down. I hope you have understood so far. So let me write down all this. Okay, then we'll proceed with the graph. We are basically looking for the graph of this in different intervals. So ultimately we are getting this sine inverse of sine x will be written is equal to okay, but all we have got x, if x is lying between minus pi by 2 to pi by 2, that is what first we have got. And then when it will go for minus pi by 2 to minus 3 pi by 2 to minus pi by 2, minus pi by 2 minus 3 pi by 2, then it was minus pi minus x. Then when x is lying between this pi by 2 to 3 pi by 2, so it will come pi minus x, and so on so forth. The rest of the things can be found out in that relation. Put n equal to, put n equal to minus 2, put n equal to 3, put n equal to minus 3, you will get recurring intervals. So ultimately we will get all the intervals. Okay, not all intervals are required. If we know this much, it is going to help us a lot. Okay, now let us draw the graph. Again, so from minus pi by 2 to pi by 2, the graph is x. Y equal to x. Okay, now it is saying from minus pi by 2, minus 3 pi by 2 to minus pi by 2, it is saying us minus pi minus x. And please remember, the range of the function was minus pi by 2 to pi by 2 only. Again, so this one is y equal to minus pi minus x. Okay, now please pay attention here. Sin x, we know that sin x is periodic with a fundamental period 2 pi. So sine inverse of sin x is also periodic with fundamental period 2 pi. So this graph is going to be repeated in all other intervals, so that we get this. Here 3 pi by 2 will come pi. So graph will be something like this. Okay, so in this case we'll get y equal to pi minus x. This. Then next will come like this. Next the graph will go on going like this. So this is the graph of sine inverse of sine of x in different intervals. Okay, I'll urge you to draw the graph, try and draw the graph of cos inverse of cos of x in different intervals. Okay, otherwise in the next class I'll be coming up with cos inverse of x, cos inverse of cos x, and tan inverse of tan x. Okay, please try and let me know in the comment section whether you have understood or not. Okay, thank you. Thanks for watching.